Okay. So, yeah. Hello, everyone. Hope you all are fine. I'm Karan Kantira, Head of Research Innovation and Entrepreneurship Unit at ESL IIT BHU. I'm really excited and happy to welcome you all to our second session on Know Your Department series. So, our aim is to enable students to have an entrepreneurial perspective of their own department through this series. And the speaker would be discussing about the research opportunities, entrepreneurial scopes, and job prospects in a department. And the session will be followed by a Q&A session. So, you guys can clear all your doubts with the speaker. And for today's session, we have Kumar Vikrant sir as our speaker. He's an ITBHU alumnus, 2018 pass out from chemical engineering, and then went on to do his PhD at Hanyang University in South Korea. And he has an astounding 47 published papers under his belt. So, delaying no more time, I would like to pass out the mic to Kumar Vigan sir. Over to you, sir.
All right, thank you. Thank you very much for the kind introduction. Um, it's a big pleasure for me to be here today and to interact with you all, and especially like communicating with my juniors. It's a great opportunity, and thanks for having me on. So I hope I'm audible to you all, and if you have like any issues, just let me know at any time. Thank you. So okay, so to start off this session, I would like to give some insight into my journey so far so that you all have some insight into, um, so as to set the context of this talk. So I joined the chemical engineering department at IIT BHU in 2014 and I graduated in 2018. So thereafter, I joined Hanyang University in Seoul, South Korea, where I am right now. And so I've been working towards my PhD in environmental engineering, which is a sub-discipline of chemical engineering, as you all might know. And so my research actually focuses on combining advanced materials like metal organic frameworks or nanomaterials with environmental engineering. And my focus is on air quality management. As you all know, like nowadays, air pollution is a big issue, both indoor air as well as outdoor air. So my lab tries to develop new materials which we can use to produce advanced filters for both industrial purposes as well as indoor air applications. So it's a very rewarding experience for me. And so far, me and my team, we have published several articles, and you can read about them on my Google Scholar as well as my website and ResearchGate. Anything you can find on there. And so we have been collaborating globally with different research teams throughout US, Europe, Asia. So on the whole, it has been an exciting journey and it continues to grow. So I'm very thankful and grateful for that. And when I was in chemical engineering department, so in my second year, um, I joined the Professor R.S. Singh's lab in chemical engineering department. Most of you might be knowing who Professor R.S. Singh is. So basically, he's a professor in chemical department. So I joined his environmental biotechnology lab in second year. It was through a DIH project. For those of you who do not know, DIH is Design and Innovation Hub. So in the summers of second year, I did a project under him where we tried to apply environmental biotechnology for removing some pollutants from the aqueous phase as well as gaseous phase. So that was my first brush, so as to speak, with research and development. And from there, I learned a lot about what research was and what are the prospects in this area and so forth. And in the third year, I got the opportunity to intern in the summers at Professor Ki-hun Kim's lab, who is my present supervisor. He is a Korean professor here at Hanyang University, Seoul, in the Department of Civil and Environmental Engineering. And especially it was a big deal for me because Professor Kim is the top one of the top 10 professors worldwide in environmental engineering. So it's a very big deal for me. And in the third year's summer intern, so I went to his lab and I worked on applied analytical chemistry and material science in environmental engineering. And from there, I figured out that my compatibility with Professor Kim is astonishing. And we developed a kind of friendship and mentorship. And so after my BTech was completed with honors, I joined his lab to in an integrated PhD course. So basically, I'll be receiving both masters as well as PhD together. I will talk about it further in my discussion. So anyway, so that was a brief background from my side, so that you have a context of what I'm going to talk about today. So it's this talk is not about me really; it's about all of you. So I want to begin discussing with what exactly is research. So the the aim of these talks about knowing your department is like it was explained before, it's talking about research opportunities and entrepreneurial aspects, and also the job prospects. So since I'm in the research field, I would like to focus more on research, but I will definitely talk about other things as well, and you can also clear your doubts with me in the Q&A session. So anyway, so for me, research is finding the truth. Basically, it's my way to serve humanity. And if you look at the overall context, so in your courses you read your textbooks and you go through all these equations and theory, so and you use technologies in your modern world in your everyday life. Even right now we are communicating with each other through technology. So what is research is all this has been possible through the development in the human sphere, through the efforts of all these scientists. So even from the childhood I was very interested in science, and as most of you are, because you selected this engineering discipline. But even when I was in the doing my bachelor's, I was quite fascinated with science. And research is a very humbling experience because you get to discover all these things and you find uncover the truth and what's going on in the world, and then you develop all these theories and um, all the possibilities, and eventually all this knowledge ends up into the textbooks which all of we study throughout our course, our bachelor's. So anyway, so it's my way to serve the humanity and the seek for the truth. So one of the important thing I would like to mention is, um, so the research field, if if you are after money, and of course we need money to live in the world, but if you want to earn big bucks right after graduating, then maybe this field may not be for you, to be honest and to tell the truth. Because there is there is stable finance in this field eventually, after years of hard work and continued um, work from your end. So if you're looking to earn big bucks right after graduating, then the research field may not be for you. But if you are truly interested in investing your time to develop uh, the human world and your understanding, as well as to help others understand the realities of world, then this is truly a fulfilling experience. So let's talk about you. Like, most of you are junior undergraduates or sophomore students or maybe even freshman students. So how to go about research, like how to get into the research field? So most of us know what research papers are, what scientists do, what researchers do from an early stage. But in our universities or in our institutes, more focus is generally on the coursework from the early time, and students actually do not get a chance to experience what a lab atmosphere is, what a good scientific practice is. So in my time, this exploratory project was introduced while I was in the third semester. So I joined various labs in the chemical engineering department just to see what people were working on. I don't know whether right now the exploratory project is going on, but at my time it was. And if you complete some extra amount of credits, you get honors with your bachelor's, like I did. I hope it still continues, because in my opinion it's a very good initiative, because the students get to experience what a research atmosphere is. So how to get into research? So I think for all of you, the first point of contact would be to explore what is going on in our own department or in our own institute, even in other departments labs. So the first point of contact will be that, like you discuss with your the PhD scholars in your department and talk with the professors and see at least what they are working on. In that manner, you will get to understand how to search for research papers. And in ITBNCU, we have access to almost all the journals, so it's very easy for you to find the full text and read the full papers. So once you get into contact with some PhD students in your department or through your professors, you get to know what they're working on. So you can get inspired by their work, like what they are doing and what are the various possibilities in the field. Then my recommendation would be at least to do one foreign internship while you are in your undergraduate, whether it is research internship or an industrial internship, it does not matter. But I highly recommend like trying to get one foreign intern, because you will get to see a very, very, very different world than what you are living in right now in India. Basically, you will get to experience different culture, what other people do, different cuisine, meeting other people. It's a very humbling experience, and it's many ways an eye opener. So I would recommend to do a foreign intern if possible in your second year or your third year. Now, if I talk about a research intern, so basically most research interns go for foreign internships in the third year. That is because by the third year you have more knowledge about your own discipline, about chemical engineering, and by that time you have had the opportunities to work with the professors in your department to maybe try to develop some research acumen. So by the third, so when we apply, so this is a very important point, and many people have also talked with me over the years, like how do we approach the professors, how do we approach the scientists to ask for research interns. So my recommendation would be, the first the easiest step is to apply directly through research programs such as mytax or dad. All of you must be knowing, like mytax is for Canada, dad is a scholarship program for Germany. So these kind of programs for various countries are available, and on the internet the information is there. And in all of these you just fill up the information and just apply, and hopefully by luck or your acumen, you may be able to get a position. But in most cases it's very, very competitive, and only a few seats are filled up using such scholarship programs. So a more elaborate way would be to directly email the professors and the scientists. Now many people then ask, how do I get the contacts of the professors in which I should apply, where do I get the emails? So many people then go to the university's webpage and then they find the emails of the professors. That is a good strategy. Other good strategy would be to simply note down the corresponding author in any papers you read. In any research papers you read, there are first authors, co-authors, and a corresponding author. Corresponding author, you will see a small uh, letter, a small email sign or a star sign just beside one of the names. So that person is the corresponding author of the paper, the person who corresponds the paper to the journals. So if you click on that star, you will get to see the email address of the corresponding author. So that is the main scientist from whose lab the paper has come from. So just by reading the paper in your own discipline, you can find out which labs are working in your field, and you can just specifically target emails to them. So, so these are the two ways of knowing. And a third possible way would be to communicate seniors, such as like me, or your PhD students in your own department, research scholars in your own department. So since they are working in the specific disciplines, they must be knowing some other international scientists who are working in that field in developed countries. So from them, you can get to know about the scientist in this field, and then you can appropriately email them asking for a position in their lab as a visiting student or a intern. So how to write an email? So, well, to, to be honest, you should be straightforward in your email. This is because most professors and most scientists do not have much time on their hand to read specific details. So you have to be on point in your email. And I would be say, just be forward and speak the truth. And what are you seeking? But a very important point in this is, don't send ever don't do not send a generic email. Always customize your email according to the professor you're sending. Spend some time in writing the email. Don't address like dear sir or dear madam. Say professor and their family name. For example, Daniel Brown, so you say Professor Brown. Or just use the family name and just add professor. For example, um, what do you have, like RS Singh, so you say Professor Singh, something like that. So it because their culture is a bit different than ours, so you have to think more internationally to approach the people. So by addressing them by their name, you are showing that you have invested effort to understand them and what they are doing, and instead of simply a generic email like dear sir or madam. In the email body, then you talk about their research, at least in a small brief paragraph. This shows them that you have invested time and effort to study their research. Now, how to do that? So just go to their Google Scholar page. Most scientists have a Google Scholar page. Go to their Google Scholar page, look at their recent research, talk about the one or two papers in the email, so that they feel good and they have an understanding that you have invested effort to learn about their research. And then just explain about yourself, that you are a second year student or a third year student and you're looking for a summer internship. Always mention for how long will you be available. Like, you'll be available for a 2 months period or a 3 months period, from this month to this month. Be very, very specific, because professors do not have much time to entertain, especially undergraduate students. So you have to be very specific, and you must put yourself in their shoes. Like, these are big shot professors who are running specific research programs. So how can you add value to their lab? Now think about it. They are going to hire you. They are going to invest the lab resources into helping you uh, come to their country and work in their lab. So they must get some benefit out of you. Otherwise, why would anyone invite you? It's as simple as that. So you have to provide a description in the email, that how can you help them in whatever 2 or 3 months period you will be staying there. So best way to do that is just link your specialty with what they're doing in their lab. For example, if you know um, coding, for instance, many of you must be learning coding from an early time. So you can say that I'm good in this code and that code, and I can help develop models and mathematical equations models, and I can model your experimental data, whatever related to their field, because most scientific research fields heavily rely on mathematical models. So your coding will be really, really helpful in addressing that part. Other than that, you can talk about your inspiration, and you found this specific particular field useful, so that you can study and help them in their lab, whatever, for whatever small period you are there. So you should always consider, when you write such emails, that how can you help them in their research endeavor, because after all, they'll be going out of their way to facilitate your travel, and to like support you while they are there in your lab, in their lab. um yeah, so that was it. Other important point I often hear is, what is the selection criteria for such uh, internships, whether my CGPA matters, whether my CPI matters, whether I have to maintain 9 pointers or 8 pointers. Like, what is the story behind the CGPA? So it's a very complex answer. So I would like to provide an overview. The thing is, after a certain period of time, your CGPA may not matter much. And this is for a fact, because I also know a professor at Stanford University, US, who is now a full professor in computer science, but he only had a CGPA of 2 out of 4. So after a certain point of time in your career, CGPA may not matter much. But think about it, while you are an undergrad student and you are applying for research positions, you will not have a very sound research background because you're still discovering, you're still exploring. You may not know whether you're going into the research field or not, whether you will go into industry, whether you will go in non-core sectors, who knows. So right now you will not have what to say, research papers or a sound background into research. So how will they judge you? So very simple formula is they will look at your CGPA, and indeed it tells something about you, that you know about your core engineering areas and core disciplines. But having said that, it's not the only factor which plays a role, because how is your acumen, how is your, what are you bringing to the table is sometimes much more important. So if you ask my recommendation would be, of course, you need to study and you need to score good marks in your exams and try to maintain your CGPA in a good range. And what will be a good range? A good range will be above 8, above 8.5. If you are into 9, well, that is also good. Don't let it fall too low. Too low will be in 7 or below 7. Don't let it fall, because although it may not be the only determining factor, but it does play an important role, especially when you are an undergrad, because how will people know about your acumen? So it's one of the indicators of your performance. So my advice would be to maintain it in a good range, but do not be only focused on that, because that is not the only sole factor, and especially later on in your career it may not matter much. So perform well in your exams, maintain a respectable score. That's it, do not think much about it. And it's not the only factor that will determine your selection, so don't worry too much about it. Other than that, so so you got a position, you got an internship, you are in talks with a professor. What then? What happens now? So what happens now is you discuss about your salary and your funding, and of course you have to network. Excuse me for that. So once you begin to communicate with professors, so many times what happens is they may say that it's okay, we have a position open for you, but they may not have the funds to facilitate your visit. This happens very often because many times professors do have fund and research takes up lots of money. So many scientists do have funds, but the problem is that fund can only be used for a professional researcher, like a person in the PhD position, a person in a postdoc position, something like that. So many times professors do have fund, but they may not be allowed to use that on an undergraduate student. So many times, although you may get selection for an internship from professors, but they may not be funding you. And well, if if you have the money, you can of course go and visit, but as you all know, surviving in a developed country without having incentive and salary is almost brutal. So always take up positions which is funded. So how to talk about incentive and salary with the professor? So in my opinion, you should be direct. You should directly ask about the incentive and what's how are you being supported. Use the term supported, like how will you be supported for your visit and for your research. Many times you get a fully funded position, sometimes you don't, so you have to look up for it. And many universities actually have a summer program. Many universities do have a summer program, so if many times professors just recommend you, just apply in that program. Or well, if they have fund to spare, then that's well and good. For example, in my visit to Korea in my third year's summers, so I was fully funded by Professor Kim. So I had enough funds on my hand to get salary as well as to get funding for the work I was going to do there. So it all depends upon the professor's projects available. Oh, sorry. Okay. So professors funding available, and the scholarships available. Sometimes there are various summer scholarships for visiting students, because many universities like having foreign students during the summer, because it helps them boost their ranking as well. So many universities do have that. So many times the professor will recommend you to apply for a certain program. Many times they don't. So in the end, my recommendation would be always look in for the scholarship. If you do not know of one, just ask the professor that, professor, please recommend me any program through which I can get funding for my visit. And if not, directly ask them whether they would provide incentives or not, because in many of the developed countries, professors cannot hire individuals without paying them, because the labor laws in the developed countries is often very much strict. So they cannot hire you without paying you. So in many cases they are going to pay you, so you just have to ask and clarify how much they are going to pay you, or how will your visit be facilitated. So you should be clear in your communication, and without disrespecting, you should you should be able to communicate delicate matters accordingly. You will get better with experience, but my recommendation would be always look for a funded project. And once you are there, uh, you have to create your strong network and develop a good relationship with your boss and also the people in the lab, because eventually if you do decide to go into the research field, it will be very helpful if you have a strong network. So having said that, so higher education, many people have over the years talked with me like, please let me know whether higher education is worth it, what should I do after my bachelor's, and whether should I go for an MS, whether should I go for PhD, where to apply, what to do. So in that situation, I would recommend higher education is a very good option if you can go for it, of course, because higher education opens lots of doorway for you. Especially in developed countries, people do not get job unless they have a master's degree. In India, just after bachelor's, you can get job, as you see from campus placements. Even after bachelor's you can get a job. In developed countries it's not possible. In developed countries you have to have masters to have a job. So, well, even in India, after bachelor's, when you join a job, eventually there will be a requirement for masters if you want to get good promotion, or if you want to higher up, go in the hierarchy of your company, because higher education is valued, and because you invest more time in learning more traits of the trade, so as to speak, so that you can get good money. For example, even if you look at your seniors in other disciplines who are working in companies, who are in the industry, so many of them go for MBA and MS later on. The reason is because you cannot move up in the hierarchy without having a master's degree. So eventually people do that. Now of course, I'm generalizing here. Now many people are happy with a bachelor's and they progress in their career easily even after joining a company, so it may not be so. But in most cases you need to have it. For example, if you join in a tech tech portion of the company, if you do an MBA, you will get into the administrative part. So then you can just mix both up and move up into the hierarchy. Other times, if you have an MS, then you can advanced in the industrial structure to get more advanced pay. So generally, having a master's is much more favorable eventually, whether you are in the core job or not. So so eventually you do need to consider, everybody considers this thing at a certain point in their lives and careers. Eventually masters comes in very handy. So if you have the opportunity to do higher education, I would say it's totally worth it. And if you decide to do, then my recommendation would be to go for a developed country or a program which comes under top 50 or in top 150. So that was for the MS part. And for PhD, so PhD, lots of well, you have to sacrifice lots of your time to do research, because PhD is not a simple course. bachelor's and master's, you have a fixed coursework, you do that, you pass the exams, you get the degree. But in PhD it's not like that, because in PhD you are researching, so there is no fixed curriculum. So you have to conduct research, publish your papers, get good data, and defend your thesis and get the degree. So PhD is not for the faint hearted, and it's only for those people who are absolutely sure that they want to do it. For example, if I give you my case, so when I was in the fourth year of my bachelor's, well, I did not even fill up the form for placements. Well, many of you will find it difficult to believe, but even my roommate at that time in the fourth year of chemical engineering was the training and placement in charge, TPO, for my batch. So he asked me that whether you would like to fill up the form for the placements, because you have to fill up a form, then only you will be allowed to sit for the companies who are visiting the campus. And I remember telling him that, mate, I don't want to fill up the form because I'm not interested in job right now, because I want to go into the research field. So so you have to have a determination like that. It should be clear in your head that you're going into research, and so then only go for PhD, otherwise don't. If you want to go for masters, MS. Now many people, while doing their masters, because if you do an international masters from a developed country or from a good university, so masters program is generally very much research oriented. So even if you're doing your MS, you will have to interact with the labs, and you will have to develop research projects. So through that, many people develop interest for research while doing MS in foreign universities. So after MS, they think that, okay, I'm very much interested in research, so let's do it. So after that, they join the PhD. So if you are not sure, if you are sure that you are going for higher education but not sure whether you are going into research or industry, my recommendation would be join MS. And through the MS, you see whether you are ready for a research program or not. If you're ready, join a PhD. Otherwise, after masters, join the industry, join some companies, and enjoy. But one new option in globally is an integrated PhD program like the one I'm doing. This is for those students who just after bachelor's know that they have to do their PhD, they have to get their doctorate, but they do not want to skip the master's portion. So it's for those students. Almost all the universities globally are now offering integrated PhD programs. So you get master's as well as PhD together. So it's a very good option, because you save about 1 or 2 years, because masters is 2 years or 1.5 depending upon which country you are in, and then PhD at least 3 or 4 years. So if you directly go for a combined program after bachelor's, you save lots of time, and you only have to submit one thesis. If you do masters and PhD, you will have to do two theses, one master's thesis and one doctorate thesis. But if you do integrated program, you only have to submit one thesis, and that will be it. So you, of course, you have to take up courses and complete your credit requirements for both, but it's a very good option. So keep it open. If you want to go into research but you do not want to skip the masters, you may think of taking up an integrated program in any of the universities alike. Okay, so that was the overall of the research field. Now if I touch upon some other fields, like many of you are interested in entrepreneurship, scope of chemical engineering, and job prospects. Now, like I already stated, I'm into research field, so I know more about research. But if I have to say, being in chemical engineering, you have very, very diverse options. Even in research, chemical engineering is closely linked to material science and engineering, environmental engineering, uh, metallurgical engineering, because you can also work with metals, especially biochemistry. Even people go into biomedical field. So if you consider from the research perspective, you have wide open options. Either you can join a chemical engineering department later on, or you can go for sub-disciplines, because nowadays the world is more interdisciplinary research. So it is, if you know about other areas and how to integrate them together, so it is considered to be very, very valuable. So if you go into research, being a chemical engineering graduate, you have, I think, one of the most open departments actually One of the most open engineering departments is chemical engineering, because all the other fields, all the other departments are somewhat linked to chemical engineering. Even physics is linked to chemical engineering, because I know certain people. Now you can go into material science and then develop like photonics or sensors or something like that. So they all come into the physics discipline. So you can go for materials physics, materials chemistry, combine that with industrial chemical engineering. Now, after completing PhD, you have two scopes. Like many people were asking me, please let me know what is the scope after PhD. So generally there are two lines. You can go after PhD. You can either become an academic, a scientist, a professor, basically an academician who joins a university or join a lab to teach and conduct research as a scientist or professor. The other option would be to go into industry. For example, my lab in which I am right now in Korea, it regularly collaborates with tech giants like Samsung and LG. I have worked with Samsung as well as LG. So all these big tech giants have big industries. They have big manufacturing sectors. So they manufacture cell phones and laptops and gadgets and washing machines and air conditioners, whatnot. So in the production of all these technologies, chemical engineering is heavily involved in their industry, and they generate lots and lots of pollution, water pollution, air pollution. So they always look out for scientists in my field who can help them develop a more sustainable option, because as you know, globally people are lots concerned about pollution and global warming and CO2 emissions and things like that. So they often communicate with us. They develop new materials for their uh, industries. So they oftentimes want us, our lab, to test how their material is performing. So we do collaborations with LG, with Samsung, Hyundai. Even Hyundai, they are all Korean companies, as you know. Samsung, LG, Hyundai, many others. So they are all Korean giants. So they all have their headquarters here in Korea, in Seoul. So they regularly collaborate with us and we help them. So many times the graduates from my lab, instead of going into academia, they go into industry. And because most companies have R&D, research and development branch, so you get a job there in the R&D branch of the company. So being a PhD does not mean that you are only going to be stuck in academia. If you want to go into industry, you are most welcome to do that. So so that was the overall from my side. Other than that, I would like to say that if you want to progress in your career, of course you can do anything. You can join non-core sector. Coding opportunities are tremendous. You can be anything, you can do anything. But the only thing is you have to find meaning in your life, because without meaning you do not take responsibilities, and without responsibilities you do not develop in life. So you have to have a sound philosophy to live by, and eventually make growth in whatever you do. Now, work nobody succeeded without working hard. So you have to work hard, put in long hours, but you have to work smart. Like many people say, you have to work smart, but you have to work smart as well as work hard, because without giving in long hours, getting success is very much difficult. So you have to work smart as well as work hard. My suggestion would be develop meaning in your life. What drives you? For me, research drives me crazy. Like I want to find out new things every day. So you have to find out something, even in whatever you do, whatever you want to do. You have to develop a perspective uh, in which you can keep on growing in that discipline, like banging it on, keep on going. So you have to find something like that, a meaning in your life, so that you have a drive to do what you want. It's like Epictetus, the Greek philosopher, said that there is a dichotomy of control. You should know what is in your control and what is it not in your control. So most things in our life are not in our direct control. So whatever things is in your control is how much effort you put in and how much zeal you have to develop your own mindset and your own performance. So that is in your direct control. So you should do that. So well, that is all from my side, and thank you for listening. And I would be very much interested in the Q&A, because I know you have lots of queries. So please ask me frankly, because I'm your senior, and I'm not, like, I graduated in 2018, so I'm not very old as compared to you. So you can ask me anything you like, and I'll be happy to answer that. And thank you for your patience and listening. Thank you.
Thank you, sir, for your wonderful section. And guys, you can ask question.
Guys, you can put your queries in the chat box, or you can unmute yourself and you can ask. Yeah, there's one question from Shashank. Uh, so, if you opt to drop out of the integrated PhD, would we have a master degree in hand?
Well, well, as far as I know, you will not have master's degree in hand, but I think it may be arranged, if, because every universities have different administrative rules. So I think if you have completed, because the credit requirements for both masters and PhD are not separated in an integrated program. As the name suggests, both parts are integrated. So I think if you drop out, I don't think you will get a degree, either master's, of course, not PhD. But I think if you have completed, for example, 4 semesters of your coursework while being in an integrated program, I think if you talk with the university administration, perhaps it could be arranged. I am not sure on this point, but I don't think you will get a degree, but it may vary from university to university. So you have to talk with the university administration to know for sure. Okay. How many years your course is, and how long would it take for separate masters and PhD? So masters, MS, it's 2 years. If you do integrated, all of them are together. Now, having said that, you have to complete credit requirements for getting the degree. So, for example, so here at Hanyang University in Seoul, and it's the same for other universities globally as well. In every semester, you can only take a fixed number of credits. For example, for me, in each semester, I can take 12 credits. So if I take 3 credit course, so I can take maximum 4 courses in one semester. So if I take 12 credits in each semester, so eventually you will complete the credit requirements. For masters, the credit requirements generally completes in 3 or 4 semesters, so that is about 2 years approximately. And in an integrated program, the credit requirements gets completed in about 5 semesters. At least I completed in 5 semesters. But since you are also have to give a PhD degree, you will have to complete your thesis requirements, and then you will have to defend your thesis. So it varies. So a general answer would be 2 years for your masters. And if you are doing PhD separately, at least 3 or 4 years. If you're doing integrated, you might be able to complete both masters and PhD in about 3 or 3.5 years. Yeah.
So you have other two question.
All right.
Yeah, it was a great talk. I want to know what would I have been doing in an industry as a bachelor of chemical engineering? What kind of work would I have been assigned?
Okay, what I would be doing in an industry as a Bachelor of Chemical Engineering, what kind of would be assigned? So i- if you join in a core chemical engineering job, so you will be managing plants, either manufacturing plants or petrochemical industries, and generally it's in manufacturing sector. So as an engineering graduate, you will be what's the exact name of the position? It's like a technical manager, technical supervisor, something. Every company has a different name for that, but you will be managing the plants and you will be analyzing the products being produced in the industry, and whatever problems are there you will trying to fix it up, or you will be trying to enhance the production. For example, some of my friends who are in, for example, ONGC, so their job is to monitor the production of petroleum from the uh, site, and then they manage the production and try to come up with solutions wherever there is any issues. And many times they try to optimize the process and adopt new technologies from scientists like me who develop new stuff. So they always look, their R&D sector always looks out for new technologies to help develop the production. So as a core chemical engineering, you will be handling, most likely you will be in a manufacturing plant or in a petrochemical site, something like that. Thank you.
So you said that chemical engineers actually have a scope to go into physics. Can you please elaborate on that more?
Yeah, sure. So of course, being a chemical engineering graduate, you cannot go into those parts of physics, especially not into the theoretical physics, no. But you will have a good chance into experimental physics. And in experimental physics, the most commonly employed shift from chemical engineering to physics is materials physics. Now, materials physics is like you develop new materials, advanced materials like nanomaterials. You must be knowing about nanomaterials. So you develop nanomaterials that are used for like luminescent sensing or biosensing, something like that. So that comes into the broad discipline of physics. Example is photonics, or you developing light diodes or something related to uh, light illumination. There is a broad field of material science which deals with the physical aspects. So you will have a good chance into, especially into the sensor part. Most sensors are a combination of material science, chemical engineering, and physics. So most chemical engineering graduates who go into physics department, they are generally associated with the development of modern sensors and photonics and things like solar cells. Even I think in our IT department, one of the professors was working on solar. Now I'm not sure about what they're doing at present, but the so what a chemical engineering graduate would do in a physics research, so they will develop new like photocatalytic materials or materials that can harvest solar light to develop energy, either energy or degrade pollutants or something like that. So it all comes into a physics discipline. So being a chemical engineering graduate, the most obvious route is to go via
Thank you.
All right, I can see. Okay, chemical engineering is vast, having many sub branches to work on. How to find which one interests you? Now that's a very interesting question, and has been often asked uh, f- mm, to me as well. So my answer would be like, being an undergraduate, you of course do not know for sure which sub branch you are going in. So the most obvious route you can take is trying out different fields, because even in your department professors are working in different fields. So perhaps you go into all of their labs, try to see what they are doing, and um, explore what interests you. If I give you my practical example, so I initially started with environmental biotechnology. So I was using microorganisms to remove pollutants from the aqueous matrix as well as air. But then I shifted my focus to pure material science and combining that with environmental engineering. So I stopped working directly on environmental biotechnology because I liked working with materials more. So so the obvious thing is you have to explore. The first thing would be to explore in your own department. Then when you go for intern in other lab, you see what they are doing, and perhaps in your doctorate you may be doing something else. So it's up to it's up to your experience and your reading and your experimental adventure that you will find which field you are working on. So as an undergraduate, it's not the time to specialize especially into one subdiscipline, but uh, my suggestion would be to explore all the subdisciplines, so you have some examples of what's going on in chemical engineering, and just pick one. Which one interests you the most? It could be material science, it could be pure environmental aspect of chemical engineering, it could be environmental biotechnology, or even chemical biotechnology. So polymer science, modeling, theoretical, fluid mechanics, simulation, something like that. So there are wide scope. Only thing to know for sure is to try them all out. So you have to briefly read about them, and maybe talk with people who know about each discipline. First point of contact would be your own department. So you try sample each one out. Eventually you will find the best one to know for sure. And bachelor's is a very good time to explore all. Yeah, so that would be my recommendation.
Just like you actually said about physics, is there any scope for chemical engineers to go into mechanical engineering or automobile engineering? I can say precisely.
Of course, I'm glad that question has cropped up, because even my research is somewhat related to automobile engineering in mechanical discipline. So how? So every automobile has a catalytic converter at their outlet. So what is used in those catalytic converters is supported noble metal catalysts, which are platinum or palladium or even sometimes gold based catalysts. So whatever comes out of your engine, it's a mixture of hydrocarbons and VOCs, which are volatile organic compounds, and some inorganic compounds like NOx, nitrogen oxides, and sulfur oxides, because your fuel contains sulfur. So all these pollutants come out of your vehicle. So how do we control that? We use a catalytic converter which works at high temperature to convert them into eco-friendly products. For example, the nitrogen oxide is reduced into nitrogen, and your organic compounds are oxidized into water and CO2, and some other compounds will be converted into some benign compounds. So what is this engineering? This engineering is chemical engineering. In your subsequent years, you will study about catalysts, you will study about adsorbents, you will study about the fuel technology. So all this is chemical engineering. So you have a very big scope in automobile engineering. And if I tell you, even right now I'm developing certain catalysts which can work under dark condition and even in low temperature. So the research field right now is focusing on developing high quality catalysts which can work in relatively low temperature to remove all these pollutants. And these can be eventually employed in indoor air purifiers, industrial effluents, and also to treat automobile exhaust. So chemical engineering is directly involved in automobile in this way, in the environmental field. And also the other application in automobile engineering would be your something like fluid dynamics and heat transfer, because you have to develop efficient engines which can utilize all your energy. And all this is part of chemical engineering as well as mechanical engineering. There's a very wide field of interest in fluid mechanics and fluid dynamics. How do fluids like gases and liquids move through pipes and other systems, and how they interact with energy, how they transfer heat? All this is chemical engineering and also mechanical engineering. So you have a good combination between automobiles and chemical engineering. I hope that's helpful. Other is for foreign internships, sir, can you give us the example of an email that we need to send to the profs? Oh, well, um, well, for this question, I would say that, well, you have to be genuine, and the best case would be to write yourself, because, well, um, sure, if you contact me personally through my email or through my website, I can give you some examples. Now, I have given such examples to many students before, so I can, of course, send you some examples. Now, the best thing would be to give a subject, like what are you writing the email for. You can either write some catchy things like greetings from Varanasi or something like that, or you can be very, very direct and just say that looking for internship opportunity in your esteemed lab or something like that, then you go for dear professor blah blah or respected professor XYZ. Then you say that you are very intrigued by the research in the first 2 or 3 sentences. Then you explain who you are, what you do, and how can you contribute in their lab, and then you just attach your CV. Many times university professors email screen out the attachment in the spam folder, so it would be better to attach your CV as a link. Now simply upload your CV on Dropbox or Google Drive, and just share the link in the email body instead of attaching your CV as a PDF, because many times that PDF goes into spam folder and the professor might not see it. So attach that, and for specific content you can write to me, and perhaps I can help you with that. Okay. Is it a prerequisite for MS in foreign universities to have published at least one research paper? No, it's not. Even for joining PhD, it's not a requisite to have published a paper. Of course it helps. For example, many people will apply to the program, so how will you stand out? Like I explained earlier, the easier metric would be to see your CGPA or something like that. But if you have a paper, you'll be very much distinguished from other people, and because it will show that you are already interested in research or already interested in the nuances of your field, so you have already invested time and effort to uh, publish something, so you have published an article, so that is always a bonus. So it's not a prerequisite, but of course if you have a paper, I can tell you from my personal experiences as well, that if you already have a paper, at least even one paper, it will set you apart from others. So it will increase your chances of selection many folds, and it will also give you a good talking point in your interviews, because you can just explain about your paper and what you did, and that will take up a large chunk of your presentation, because many labs do take an interview, so you have to be prepared for that. So having a paper is always a bonus, and I recommend that you please try to publish in your undergraduate, if you can, of course.
Sir, actually, there was one doubt. As you are in research field,
Mhm.
every time someone says research, I feel like no, this is actually something like a space science. And how do we do that? Is it like that you go to the board, solve some equations, and they go to the lab, try that out? If that doesn't work again, go to the board. Is that work like that, or is it like something hi-fi science involved in that?
All right, uh, so well, that is why I recommend that you experience developed country laboratory in your undergrad if possible, because you will get to experience what, well, real research looks like. um, but it's not, perhaps this kind of feeling may be coming from well, sci-fi movies or shows, I don't know. But to be perfectly honest, so research, basically we take a problem and we try to solve it. Now this can be, can sound very magnificent, or it may sound very superficial. For example, like we in my lab, we devote lots and lots of time to develop better instruments, better applied chemistry instruments. Now a layperson would say that what kind of benefit you are doing to the humanity by developing a better instrument that can measure even parts per billion levels of gases. Now that is very useful in practical situation, because in industry and in also in normal circumstances you have to measure the gas. So until unless you have a very precise instrument, you cannot do that. So in this way we are contributing towards that. Other things would be to first find the problem statement and then looking for solution. For example, in my case, my problem statement right now is to developing good purifiers for the industrial effluents, like the gases which come from the industry. And it's very critical to develop modern technology in that respect, because the present one is unable to solve all the problems, like it's unable to capture all the gases. So we have a problem statement in mind, and we then study about what the present technology is, what was the history behind that, and then we try to advance that technology into new ones. As far as equations and models are concerned, well, in my office I do have a whiteboard, if you're interested in that sort of thing. And we do write down equations, and we do model the all the fluid motion, and we do simulate that using softwares. And yes, we do try to find out the optimum solution. So we do solve equations. You should have a good mathematical background to be able to understand all the possible solutions. Integration, differentiation, especially differential equations are very much useful in research. So of course you should have a sound mathematical background. We do use blackboards, we do solve equations. But when you go into research, so in essence, if I should explain, it's finding a problem statement and solving it. It may be, the problem statement may be in rocket science, it may be in soil science, like how the soil of one part of the world is losing all its nutrients. For example, if you know about phosphate is a very, very big issue in the world. It's not as glamorous, if I can say. For example, rocket science and astrophysics perhaps may sound more glamorous because you're talking about going out of your planet and things like that. But other disciplines are also there which are equally important. It may not sound that exciting, but it's very, very important to solve those problems. For example, phosphate on the planet does not go in a full cycle. For example, there is a carbon cycle, there is a nitrogen cycle, but there is no phosphorus cycle, because phosphorus comes from the rocks, but it does not go back to the phosphorus rocks. So what we are doing right now, even I'm involved in that aspect to a certain respect, that we try to capture the phosphorus back from the fertilizers which we apply in the soil. So when we apply phosphate rich fertilizers to the plants, now only a certain part of it is taken up by the plant, the rest is washed off from the soil. So it goes into the river, it goes into the lake, it causes eutrophication, the growth of algae and other well, not so good species of plants. So we try to capture that excess phosphorus back from the water, and so that we can reuse it again and again. So if you think about it, it's a very, very important research, but it may not sound as much glamorous as designing a rocket to go into space. So yeah, so that would be my answer. um, all right, I see one more. If only experimental physics is possible, then is going for theoretical physics for chemical engineering impossible? Well, I cannot say anything is, well, most things are possible in life. And of course, if you want to go into theoretical physics after graduating from chemical engineering, you can. I can give you a very practical example. One person, even an Indian student in my lab right now, he completed his master's in theoretical physics, if you can believe that. And he now is doing PhD in the discipline which I'm doing, which is environmental engineering and chemical engineering. So if a transition from theoretical physics to chemical engineering is possible, of course, the other way around is also possible. It's up to you. What I meant when I said was the experimental physics is easier for chemical engineers because experimental physics is application-based technology. Okay, you develop technology for application into the real world. And in that case, chemical engineering is a very, very practical branch because our field is interested with real world problems. So a transition from chemical engineering to experimental physics, you will find much more easier and much more connected to your discipline than theoretical physics, because theoretical physics is something very different. And if I can correlate, that is the thermodynamics is very much close as far as you can go in theoretical physics and chemical engineering if you want to link them directly. Of course, after bachelor's, many people change their discipline. I know people who studied English literature in their bachelor's but did their master's and PhD in evolutionary biology, if you can believe that. So life, and of course, if you want to, if you're interested, you can do, of course you can do. I just meant that it is more easier to get into experimental physics as compared to theoretical if you transition from chemical engineering. All right, where we can get your email address, I I will write it down in the chat box. First, let me answer me this last question, I think. To what extent does an industrial internship give us a feel of what working in the industry is like? Well, of course, um, it's very, very eye-opening in many ways, because while being in the college you only read about theoretical stuff, like this is the theory, we apply it like that. But in industry things are very very different, it's on a very very large scale. So if you get a chance to visit an industry, is I recommend everyone to do it. Even I did it. So I visited coal plants, and I also visited a petrochemical plant, um, petroleum refinery. So if you get a chance, do visit an industry, because it will open your eyes, because you will see how the things you are studying right now is being applied in the industry, and perhaps through your visit you will be able to forge connections with people in the industry. So in that way you will get a very broad perspective, because in industry everything is on a large scale, it's very different from theoretical. Of course I recommend please do industrial visits, or even internship, it's possible, it will broaden your horizon. Sir, can we do masters in some engineering field other than some chemical engineering field? Of course. I did it. Like I graduated in chemical engineering, but right now I'm in civil and environmental engineering. So that explains it. I'm in a different engineering field if you label it like that. But since after a certain after a certain level in the academia, all the fields begin to come together. There is no longer a very much difference, because in the actual world everything is interconnected. In everything you can find one subject, other subjects integrated together. So after a while it does not really matter. But of course you can change disciplines, and even like I explained, people are doing history and literature coming into science. I know somebody who did uh, bachelor's in engineering, but later on they studied history and became professor of history. So anything is possible. Of course you can change your branch and go into different engineering department. How to know whether we should go for research internship or industrial internship? Well, ideal answer would be try to do both. um, Perhaps go for industrial internship in second year and research in third, or if you get good industrial internship in third, well, go for that. But maybe try to go in some research lab in the second year, even within India or outside India. So my recommendation would be to try to experience both if possible, because that will give you more opinions and try to reach conclusion like which sector is better suited for you. So my recommendation would be try to do both under practical circumstance. If for example, ideally you are getting both industrial as well as research option, but you have internship and in dilemma which one to choose, well, I cannot give you an answer, it's up to you which one you want to do. But if you are getting a chance to experience a different culture, go abroad and see what other countries are like, what other peoples are like. In my opinion, um, having a cultural experience is very much valuable, because it opens your third eye in many ways. So but it's, of course, it's up to you. If you are getting good chances in both locations, it's your decision which one to take based on the circumstance. So we can also do masters in computer science if you belong to chemical engineering. Of course you can. Of course you can. What will be the requirement for that? The only one to get into masters of computer science would be that you should have a bachelor degree in engineering. If you have a bachelor in science, then perhaps you cannot join the engineering discipline of computer science, but you may be able to join only the science part. But the only requirement in my perspective is you should have a bachelor's degree. Most, if you look through the prospectus of most universities, they do not ask you whether to have the same bachelor's in the same field. So if you have bachelor's in different field, you can of course join in different field. Like I explained earlier, people are doing science and engineering degrees but then going into literature, which is art. People doing bachelor in arts going into science and engineering in masters. So you can definitely join masters in computer science after your bachelor's. It's completely possible. You just have to need to look up the university requirements. Generally they only ask whether you had bachelor's or not. So you can change your field after bachelor's and while you go into masters, but beyond masters it may not be possible. to change your field. Only thing possible would be to go into specialization of that field. So if you really want to change your field, the best time would be to get a master's in the field you want after your bachelor's. You can indeed change your branch, or I should say change your field. Yeah, that's possible. Oh, I'm sorry. Ah, sorry, there was some technical problem. Anyway, so in the chat box, writing in my, so I put in my website into the chat, and you can get more information there. My email address is there, and also my other details are there, so you can just, yeah. I think it was a, yeah. Oh, sorry, it
Not
was,
visible.
okay. So I think now everyone can see my message in the
Yeah.
chat box. Yeah.
Yeah.
So you just visit that website, and my email and other details are there, so you can just contact me through those email. Yeah.
Okay. So I think we are done with all the questions, right? So thank you very much, sir, for such an informative session, and
Yeah.
yeah, and also thank you to all the attendees for making it so interactive. And I think I believe all your queries are clear. So yeah, thank you everyone. Bye then.
Yeah.
Can end the meet now.
Thank you very much for having.
Yeah,
Okay.
sure, sir.
Yeah. Take care.